Hello again, and welcome to week 5, where we continue working on the Open Modelica simulation we started in the previous week. So far, we have built the IEEE 9-bus system and added controllers to our model to assess its power dynamics. This week, we will build on our simulation by adding time-varying renewable energy source to the existing network. The objective of this week is to explore more functionalities of Open Modelica to assist in power system modeling. We will do this by adding a wind farm to our model. Wind power parks are relatively easy to integrate into power systems in Open Modelica. The complete model will have the topology as shown here. This is also figure 6 in the modeling companion file. Make a copy of the network file from last week, as we will make additions to this new file now. Let us start. Start by locating the wind plant model in the Dell model library. Drag it to the network model workspace and name it Gen 12. Now add 2 transformers and a line. Make the connections as shown in figure 6. For our convenience, we have already taken care of this in a new model. The lines and transformers can be parameterized with data from the MatPower case file. Finally, initialize Gen 12 with values from MatPower load flow results. An important remark here: the generator P and Q values for Gen 12 need to be entered as negative of that obtained from MATLAB load flow results. For example, if P equals 10 in MATLAB load flow results, this should be entered as minus 10 for P underscore 0 in Gen 12. Gen 12 has an input for wind speed. This can either be set to constant, random, or given a wind profile. For this particular case, the base wind speed is 19 meters per second. We will now input wind speed from a text file into this model to give it a more realistic representation. Download the wind speeds text file available on the course website. Drag the component Combi timetable from Modelica, blocks, sources, Combi timetable. Place it near Gen 12. Open the Combi timetable element and fill the following information. Table on file is set as true. Table is set as fill, brackets 0, 0, 2. Table name is tab 1. The file name should be set from these 3 dots and selecting where the wind speeds file is located. The smoothness should be set to constant segments and extrapolation to hold last point. If load 7 in the network workspace has a step input connected to it, change the height of the step input to 0. Simulate the system for 100 seconds with an interval of 0.1. We will observe power output from the wind plant, the voltages at generator buses, and the frequencies from the synchronous generators once the simulation is completed. These are the voltages at buses 1 and 2. Let us see the power output from the wind generator. It's quite variable. And now let's observe the frequencies of the synchronous generator. As we can see, the wind plant with a variable wind profile has a disturbing effect on the power system. The frequencies as well as the voltages in the entire system are variable due to variable output of the wind power plant. This concludes our video tutorials. Now it is up to you to create and simulate your own models and power systems. Good luck!